before your mind even catches up with what you're seeing, pay attention, because what Perseverance just recorded on Mars was never meant for casual viewers. It's not in NASA's press briefings. It's not written in any scientific archive. And believe me, this is not the kind of discovery you pause, skip, or ignore. What you're about to witness is untouched, unfiltered. The kind of Martian evidence that forces experts to throw out their first explanations and start from zero again. In the next moments, you'll see something from deep inside Jezero crater that NASA hasn't fully addressed, and maybe doesn't know how to. So if you're new here, hit subscribe and turn on notifications, because on All About Mars Surface, we don't recycle what everyone repeats. We reveal what no one expects you to see. In this episode, the Perseverance rover stands quietly on the rugged edge of Jezero crater, staring into territory no human or machine has ever surveyed so closely. Moments later, the rover rolls forward, inching toward a massive rock formation NASA has labeled Pico Alto. But reaching it is no easy task. Soft sand, rising slopes, and a stubborn wheel motor keep forcing the rover to halt. Engineers back on Earth spend several days restarting and debugging the system, hoping that Perseverance will overcome the issue. Then comes Sol 1334. The rover pushes through, traveling 107 meters in a single stretch, and finally parks at the foot of Pico Alto. From this vantage point, the long arc of the rover's tracks curves beautifully across the Martian soil. Thankfully, the rover is now on firmer, safer ground. Here on the left is the pale western face of Pico Alto. After a few precise maneuvers, Perseverance stations itself beside a light-colored patch of bedrock that NASA's team believes hides important geological secrets. Without wasting time, the robotic arm extends, the abrasion tool begins to grind, and a perfect circular patch emerges. A quick inspection shows the abrasion bit is still in excellent condition. Watson camera swings into action, capturing a detailed sequence of images. These photos reveal something unexpected. The patch contains a strong signature of olivine, a mineral that may hint at Mars's volcanic past. With the science data secured, Perseverance turns toward Pico Alto again, capturing a fresh mosaic of its layered textures. At first glance, these stacked patterns look like classic sedimentary formations, the kind shaped by flowing water. But water at this altitude would rewrite Martian history entirely. A closer look reveals that the layers tilt and twist, proof that these rocks were forged by something far more dramatic than water. Next, the rover takes a final mosaic of the abrasion site, now named Rio Verde, before beginning a climb toward its highest target yet, Lookout Peak, a natural balcony on the crater rim. The first drive lasts nearly 2 hours. In the images, the Martian sun slowly dips lower, casting long beams directly into Perseverance's cameras. The rover is literally driving into the sunset. A shorter drive on Sol 1347 reveals a strange brick-shaped rock immediately flagged by NASA. Orders are sent. Scan it with SuperCam. Later, on Sol 1372, the rover pauses and glances back. Pico Alto is now distant, a reminder of how far it has climbed. A bit of sand still clings to the rover's wheels, evidence of earlier struggles, but it should fall away with time. Driving becomes easier as the terrain grows rockier. Small stones help the rover's autonomous systems lock on to features, instead of slipping over smooth, empty ground. After climbing hundreds of meters over the last few months, Perseverance is now just steps away from escaping Jezero crater entirely. One final push, and the rover reaches Lookout Peak. Here on the razor-thin edge of the crater rim, NASA commands a full 360-degree panorama. For the very first time, Perseverance peers over the boundary of Jezero crater into a brand new world. Ridges, mesas, and distant features match the maps drawn from orbit, but seeing them from the surface is something else entirely. Strong winds whip across the rim, so NASA activates the SuperCam microphone. What you're hearing is some of the harshest Martian wind captured so far, recorded as the rover studies a nearby rock. When sampling is complete, the rover begins its descent toward the vast plains beyond the crater. Over 2 sols, it travels 263 meters and arrives at a new location called South Fork. From here, Perseverance continues taking images, framing the terrain ahead as it slowly lowers itself into new geological territory. At Clearwater Basin, NASA orders another abrasion. It goes flawlessly. Watson records a new image sequence as scientists begin comparing this region's rocks with those inside Jezero, searching for clues about the lake that once filled this crater billions of years ago. The episode begins with Perseverance parked near the rugged northern rim of Jezero crater, a 45-kilometer-wide basin that once held a vast Martian lake. For more than 1,000 sols, the rover has been working its way across ancient deltas and volcanic plains. But now, it stands at a threshold. Beyond this rim lies terrain that orbital images have captured, but no rover has ever explored. The rover's cameras sweep across the horizon, capturing a panoramic view of jagged ridges, sloping valleys, and distant, faded Martian hills. The light is sharp, the shadows long, the kind of view that reminds us that Mars is still a wild frontier. Perseverance receives its next command: climb the crater rim and reach a massive outcrop NASA calls Pico Turquino. What's waiting there? Layers of rock, but not just any layers. These formations could reveal whether Jezero once hosted water long before the lake we've already discovered. So Perseverance begins its approach. Perseverance is ordered to attempt the climb again, this time with new safety parameters, cautious speed limits, and improved traction algorithms. And then comes Sol 1338, the day the rover breaks free. With a steady hum, Perseverance drives 107 meters in a single continuous move, pulling itself up and over the hazard. When the drive ends, the rover finds itself right beside the western flank of Pico Turquino. Behind it, a sweeping trail of wheel marks curves across the sand like a signature written into the surface of Mars. Ahead of it lies one of the most scientifically intriguing formations of the entire crater rim. After a few delicate maneuvers, the rover positions itself beside a strange, light-toned patch of exposed bedrock. This rock stands out from the darker terrain around it, almost like a pale scar on Mars's surface. NASA's geologists believe this may be a key to understanding what kind of environment existed here billions of years ago. Perseverance lowers its robotic arm. The abrasion tool starts spinning. Martian dust scatters in tiny clouds. Bit by bit, a circular patch is carved into the rock. A quick system check. The abrasion bit looks perfect, still in excellent condition after dozens of uses. Now, the Watson camera is activated. It moves close, adjusts focus, and captures image after image. When scientists analyze the color, texture, and composition, they find it: olivine, a mineral that suggests the rock may have formed deep underground before being exposed by erosion or ancient volcanism. This single patch opens new questions. Was this area shaped by volcanic flows? Was this part of Mars's crust billions of years ago? And what forces lifted this rock so high on the crater's rim? Perseverance records everything. Then, once the data is secured, the rover lifts its masthead and captures a fresh, high-resolution mosaic of Pico Turquino from this new angle. At first, the formation looks like sedimentary layering, Horizontal lines stacked like pages in a book. But something is off. A closer look reveals many of the layers tilt sharply, breaking the pattern expected of water-shaped rock. This isn't sediment. This isn't the work of a lake. This is something far more ancient. Something that formed long before Jezero ever held water. This terrain isn't just challenging. It's exhausting for the rover's mobility system. But Perseverance keeps climbing, guided by decades of engineering, millions of lines of navigation code, and the determination of the scientists watching from 300 million kilometers away. The air becomes thinner, the wind grows stronger, and the horizon starts to change. Perseverance is getting close. In the next chapter, Perseverance continues its steep descent and encounters some of the strangest rock formations of the mission so far. A special thank you to our members and supporters. Your contributions help us bring the Martian surface to life in every episode. If you enjoy this journey across the Red Planet, don't forget to like, share, and subscribe. And click here to watch the next episode of All About Mars Surface. Thanks for watching, Dara friends.